All right, welcome to study hall, everybody. Sorry for the delay today. I was troubleshooting an issue, trying to get it at the bottom. I'm having an ongoing issue with OBS, and I'm just trying to get systems in place to mitigate it if the problem occurs again. I'm hoping it doesn't occur ever again, but it's been sort of an ongoing issue, unfortunately. So I'm trying to get that figured out. But everything's good to go now, and hopefully it's smooth sailing from here on out. So if you're new to study hall, I know we had a cohort just start recently. If you're new to study hall, then welcome. This is a place for you to come and ask your questions in a study hall environment, right? So you can paste your questions in the thread, somewhat like if you're in Premium Prep, you'll be familiar with how the threads, what role the threads play in class. So similar sort of deal. So you can just click right now where it says one reply, and I have that reply in there on that message for the link to study hall, and paste in your problems. So if you're working through something, just please include a link to the problem in Learn if it's from Learn. You can also paste in like a Code Wars problem or something to it. I can take that on stream. So we have a few options of what to do today. I'm still, as usual, I'm kind of flip-flopping between, should I go through the material? Should I go through Code Wars? Kind of leaning towards Code Wars. I think we haven't done Code Wars in a little bit, so it might be fun to do that. So let's just pick a Code Wars problem, and I'm going to go through it and just talk about how I approach solving it and everything. And yeah, so that's what I'm going to do. If I don't have any other questions to go through at the moment, you may feel free to ask questions about what I'm doing at any point. But mostly, the purpose of the study hall is, the way I like to do them is the purpose of them is to give you a venue to ask your questions and talk about where you're stuck and what you want help on, and go from there. Cool. All right, let's get the difficulty setting here. Okay, cool. So actually, we'll come back to that because it looks like we have a question. Thank you. So let me copy this link. And we'll go here. Whoops. Oh, okay. Well, didn't copy the link. Copy that link. Okay, cool. We've got a dictionaries question. And this person is providing some of their own code and an error that they're getting. Let's paste that in and get going. So this is the code. Looks like this is the error. Not sure if this is. Okay. That's that. That's that. Okay. So dictionary is number one, and is this the first? I know there's a bunch of challenges in this one. Let's see. This one's just called AddValue. AddValue. Okay, cool. So this is the first one. Okay, so write a function called AddValue. Given an object and a key, AddValue sets a new value on the given dictionary with the value of true. So it's just kind of nice. We get a little test here. what amounts to a test. We'll have to kind of turn it into a test. So this is saying, given an empty dictionary, we call AddValue, and then we print the dictionary, and that should say true. So if I, presumably also if I print just the dictionary, and I'm just going to call this D actually. If I just print the dictionary, I should get a value of my key, colon, true, like this. So this is kind of a weird one because the behavior that they're describing, I actually kind of want to remove this problem from our materials because this is actually asking you to do something that I recommend always avoiding, which is, here we have a function that is intended to mutate its input. And that's a behavior that you basically always want to avoid. But let's just run this. Let's kind of like look through your code, and we'll go from there. Oh, wait. Is this? Oh, challenge 2. There it is. Okay, sorry. I just saw that comment. I was like, am I on the wrong one? Looks like we're on the right one. Okay, cool. So let's just go through this and see what's happening. I presume I'm going to get a similar error. Okay, so this is interesting. So maximum recursion depth exceeded. And right now, right now what I see is what you've done here is you've written a recursive function accidentally. What a recursive function is, and this is legal to do. You're allowed to do this. In other words, Python will allow you to do this. And there are times when this can be very useful. It's a whole technique, and it's a whole kind of can of worms getting into recursion. It can be really cool. There are problems that can only be solved with recursion, which is kind of mind-blowing and really interesting. But basically what a recursive function does, if I say def, let's make a counter. We'll take in some number n, and we'll print, we'll print, we'll just count down from n. We'll print counter n minus 1. And then we'll stop when we get to 0. We'll just return. Yeah, we'll just return. Okay, so if I do counter, and we'll just do 10 for now. So this is just sort of a side example. Name, add value, oops, excuse me. None, because of course I need to return this. Oh God, it's been so long. We'll return counter minus 1, and then this one will just return 0. And let's actually print that off. Let's try that. It's going to return 0. Okay. N. Okay, sorry about that. So you can see this is just decrementing n, essentially. So this is actually, I'm using a function here sort of to call itself as a, and I'm using it as sort of a looping structure. So right now, this is sort of similar to a while loop. So that's the kind of thing that recursion is useful for. It's sort of a super duper ultra powerful while loop. So, and I just wanted to kind of explore that a little bit just to show you, if you're writing a function and you try to call the function within itself, you better be trying to do something like this. Otherwise, you may have to rethink your approach to solving that problem. So for this one, I think the intent here is, AddValue takes in a dictionary and a key, and then AddValue is meant to give back that dictionary with that key. So what we want to do here is actually just return, we're actually going to return the dictionary. And we're going to add the key into the dictionary like this. Dictionary sub key equals true. That's all we have to do. And in case, I'm just going to call that D again. That's what I prefer to do. And then that'll take care of that. So this, if I submit this, it should just work as such. So that's it. So I do want to circle back around to what I was saying initially, which is this is doing something that I recommend always avoiding. The recursion thing is just something that I wanted to mention just to kind of give you a sense of what was going on there. That's not as important for now, unless you know what recursion is and you're learning it or something. We don't cover it in our material. It's more of an advanced technique than we really get into. But if you're writing a function, just write, for now at least, just avoid calling that function within itself. The thing though to avoid with this is writing a function that mutates its inputs, right? So notice I have this dictionary, and let's call this, oh no, call it this dictionary. So this dictionary is an empty dictionary. So let's print this dictionary. And so we'll print this dictionary before, and then we'll print after. Right? So let's do it like this. So we're not gonna see what that returns now. Right? So all we're doing is printing the dictionary twice. That's all we're doing. So first the dictionary is empty, and then next the dictionary has been altered to have a value inside of it. And you might think, oh, well, that's a useful thing. I should write functions that do this. I'm gonna tell you, always avoid this. You always want to avoid writing a function that causes one of its inputs to change. I've never encountered a situation personally where it was absolutely necessary to write a function that had this kind of behavior. I'm not going to say that those situations don't exist. They probably do. This behavior is allowed because in some sense it kind of has to be allowed. I am aware that certain situations do require this, but honestly, they're very rare. And I would tend to think that if, unless you're doing something very special, if you're in a situation where it's required that you write a function that mutates one of its inputs, perhaps there was a design problem, somewhere else in the overall structure of the program, that could have been where that problem could have been addressed, and you wouldn't have to do things that way. So for now, even though knowing that potentially there are situations where that might be necessary, the rule of thumb is to always avoid writing a function that causes a change to one of its inputs. So what you can do instead, what we could do instead is d equals d dot copy. Oops. So notice this returned a value. This returned the dictionary with the altered value. It returns a separate object. And what I did here is, rather than I still mutated a dictionary, but I copied the dictionary before I mutated it. And in doing that, I avoided changing this dictionary. So notice when I print this now, I print just an empty dictionary. I pass in that dictionary, and then I print that dictionary again, and it's empty again. So if I really wanted to cause a change to this, to the identifier, the variable called this d, I can do it this way, right? And then I could print this d like that. Oops, wait. Oh, I totally did that on the wrong line. I was like, wait, what? Okay, so let's do before and after. So if I really wanted to overwrite this, I could sort of do that. And this isn't causing, now I have a function that works in a safe, straightforward, predictable way. It's not going to alter its inputs. It's not going to cause a mutation to its inputs. It's just a safe, straightforward operation that's not going to have any weird side effects. But if I wanted to alter this variable, I can just set it equal to what this function returns. So I still have the option to do that, sort of have that sort of mutable-like behavior if I want it, but it's not always going to do it that way. And if it does cause a mutation like this, which this is not really a mutation, but if it changes the value of this variable, it's because I explicitly asked it to do that, rather than having the function implicitly doing it, right? So when you write a function this way, when you're using copy, this means, and you're returning a value instead of just relying on a mutation, this means that your function behaves in a safe and predictable way, where it's not going to alter data implicitly or secretly without you anticipating that it's going to do that, because that's where the problem is you use a function, it causes a change that you didn't anticipate. If you approach coding that way, your code can get very difficult to maintain very quickly. So if you approach coding this way, then you have a function that just gives you a version of something back. It doesn't alter the input. And if you want to cause the change, you can just explicitly state, yeah, I'm gonna overwrite the value of this with a new dictionary. So the funny thing is, I think this won't work in this problem. I think it's not going to give me the right result. Yeah. So we have to rewrite this. This I would consider, this problem I would actually consider a bug. So I'm actually going to Slack this to myself as a reminder and come back and address that. All right. And do we have another one? Or is this the same? Oops. Is this the same link? I think this is the same link. Yeah, it's the same link. Okay, cool. Hopefully that was helpful. Let me know if you have any follow-up questions or whatever. Cool. Yeah, you're welcome. Great. I'm going to give folks just a minute. I'm going to mute my mic for a minute and just put a short timer on. Feel free to pop in another question. If I don't see anything, then I'll get started working on the Code Wars problem. All right, somebody's telling me they're having problems solving a certain question. If you can send me a link to that question. Oh, yep, there we go. And there it is. Okay. Thank you very much. And I'll pop that in. We'll go from there. Question 3 on the importance of docstring. So complete this function according to the docstring specifications. All right. So let me pull in your code. Okay. And then was there an error included in that? Nope, just that. Great. So I'm wondering what error I would get if I submitted this. Let's see. Let's run it there. And then I'm not sure how to test it, but I guess we'll just start with this. Go from there. Tests canceled. The test took too long to execute or used too many resources. Okay, interesting. So basically, my guess is that it timed out. So I see this while loop. Right away, my first guess is that the while loop is running infinitely. Because that's what while loops do. They get into infinite loops kind of constantly. I'm not sure if this problem can be solved with a for loop. If it can be, we definitely need to use a for loop, but because it'll be safe against an infinite loop. One thing, so the docstring, the docstring always goes first. The docstring is always the first thing in if a function has a docstring, not all functions necessarily have a docstring. They don't require one, but by convention, it always goes first. And I'll show you why. Why don't I just show you? Let me justify that. So if I say help, if I use the help function, and I want to get help on this function, you can see help knows to grab the docstring. But if the docstring is not first, if I have, let's say I have these, if I have these in front of the docstring, help can't find the docstring anymore, right? So this is why we call it a documentation string, because Python has tools built in internally to find that documentation, right? So there's help, and there's other tools as well that know to find that each function's docstring if that docstring is the very, very first thing inside of the function. So that's one thing. So we'll move those down here, and then let me read through this. And first thing I want to do is devise a test. And what I recommend is, and I recommend with this with Code Wars and with Learn as well. This is the place to submit your code once you've got it working in your own local environment. I wouldn't use this as a place to actually figure out the problem. I would go over to Replit. If you don't have a local environment set up, you can use Replit or Google Colab, and those are just through your browser, and you can start coding right away. You just go to the site and just start coding. As long as you have an internet connection, you're good to go. But then with if you have a local environment set up, obviously I recommend doing there. But so whatever your preferred environment is, whatever environment that you're comfortable using, just start with that, and yeah, go from there. The reason is you have to, when you're working, you have to develop your own tests. And there's something about like writing out tests that really helps you understand a problem. They don't have to be terribly complicated tests. Testing itself is a pretty simple idea. It's just given a certain function, you're making some sort of assertion that says, given this function, given these inputs to this function, I should expect this output, right? You know, so if I had a factorial function, factorial 4, given the input 4, I expect my factorial function to give me 24. So something like that. So in this case, let's start with a test. And I haven't read through this at all. Well, I'm about to figure out what it's supposed to do. So print. Okay. So this just takes one input. So this function calculates the Collat's conjecture from a string value that is functions. Okay. From a string value, this function should half a number if it is even. So this is what I like to do. This function should half a number if it's even. So I'm going to start kind of structuring this like code. So if a number is even, half the number. Half the number. If a number is odd, it should, multiply the number by 3 and add 1 to it. I'm just going to do those on 2 separate lines so I know there's multiply by 3, add 1. Okay, this process should repeat until the number is 1. So this, it's starting to look like actually this probably should require a while loop, but my guess is that this is in an infinite loop, but we'll kind of get into that and figure out what's happening here. So the parameter is an initial value. This is the string. This is the starting value, where to begin calculating from. Okay. I was reading this as string. I was like, what is going on? Gosh, my dyslexia is in overdrive today. That's great. Somebody's asking, test for a function would be a print. Yeah, I write these little tiny test functions like this. Testing is like a whole big topic, and there are formal testing tools. This is not a formal, print is not a formal testing tool, but it basically, you know, you can cover the same bases in a small project with just a print test. So this is a good place to get started with like the paradigms behind test-driven development. But so yeah, I just print out, if my function has a return, I can print out the function call and then see the result. So let's start with something like 10. And let's see what we're supposed to return here. So the parameter is the initial starting value. This is the starting value, where to begin calculating from. We're going to return a data tuple, which is a tuple. This should contain the, and I'm going to do this. I'm going to do bullets. Start value, largest number reached in the calculation, and the number of iterations it took to reach the value of 1. Okay, so start value, so that's easy. That's your initial value. Okay, so now what I like to do, I'll just take a comment somewhere. So this tuple should return, this function should return a tuple containing the start value, which is 10, the largest value, and a list of the number of iterations that it took to reach 1. Okay, so let's just kind of do this in our heads real quick. So this is the logic right here. This is kind of the heart of the logic. So I'm just going to pop this down here. We're going to start at, we're going to start at 10. So 10 is even. Right now we're on counter is going to be 1. And largest number encountered equals 10. Okay, so I'm just going to keep track of what's going on in here. So for our first iteration, 10 is even, so num equals 10. 10 is even, so we're going to half it, so that's 5. Okay, oops, so that's 5. Okay, so for our second iteration, we're going to multiply 5 by 3, which is 15. And we're going to add 1, which is 16. Okay. Third iteration, and this is, we've encountered a next largest number. Third iteration, we're going to half 16 because 16 is even, so we'll half it to 8. Fourth iteration, 8 is even, so we're going to half it again to 4. And I mean, I can see it's going to, since 8 is actually, you can tell as soon as you hit 16, as soon as you hit a power of 2, 16, 32, 64, or 8, or something like that, as soon as you encounter a power of 2, it's going to just half it until it reaches 1. So let's see here. So for the fourth iteration, we half it to 4. So for the fifth iteration, we half it to 2. For the sixth iteration, we half it to 1, and we're finished. So I believe that the largest number should be 16, and the counter should be 6. I might have gotten this counter wrong, maybe 6 or 7. If it's 5, I don't know. But yeah. Okay, so now I have some reasonable assertion that this should give me some tuple that's like this. And like I said, I might have fudged this a little bit, but I know it should give me some number close to 6. So if that's a little bit off, it's not a huge deal. I don't want to go through hand calculating that again. Okay, cool. So data, count. Okay, so let's see where this counter is being incremented. Presumably this is going to be the count. So that's going to be here and here. So I notice this is going to happen no matter what. So we can just pull out those counters and we can just do this straight out of the gate. First iteration will increment our counter. This condition is going to break. So while init value, I'm going to say, is greater than 1. And then that way, if it's ever equal to 1, then I know I'll need to stop. Okay, so if the init val over 2 is 0, so this is if it's even. So init val over 2. Oh, I see. That's why. So this was in an infinite loop. So init val over 2, this expression gives me half of init val. In this case, we're starting at 10. It's going to give me 5. But this 5 just goes nowhere. It doesn't. Nothing captures it. It's not used anywhere. So what we probably want to do, is say init val equals init val over 2, and then this is going to append init val. Let's see here. Did I? So we need the starting value, the largest number reached in the calculation. Yeah. So I think what I want to do, I'm just going to say largest num equals, or what did you have here? Largest num equals, we'll start it at init val. And then at some point in here, I'll say if init val is greater than largest num, then we'll say largest num equals init val again. We'll save that new init val. And I'm wondering, what did this, it does call it init val. So I also kind of want to, it's kind of weird calling this init val, but I guess actually that kind of makes sense because yeah. Actually, I'm going to do this. Val equals init val. And then wherever we see init val in here, I'm just going to replace it with val. And that that's not really changing how anything's working. I just feel like it's a little more semantic. That way we're not, because init means the initial value. So it's kind of confusing if we're thinking about it as an initial value and then changing it to something else. So let's just do this. I'm just going to say odd and even. Okay, so I changed a little bit up here. I'm capturing the largest val, because starting off it's going to be init val is the largest val thus or yet encountered, and then we're going to go to val equals init val, and if val is, or while val is greater than 1, we're going to increment the counter. If val is an even number, we're going to half it, and we actually don't need to append it to data. I see what you were doing there, and you were doing the max of that. I think the intent was to do the max of the data list like that, but I'm just going to pop in largest. Like that. Yeah. So we won't need to do that append. If it's odd, we're going to multiply it by 3 and then add 1. So this is a case where we don't need parentheses. The PEMDAS, the order of operations, is going to handle this correctly. However, you should always use parentheses anyways. The pattern inside of parentheses should be one expression, one operation, and then another expression. So val times 3, and then once we get the product of val times 3, then we add 1 to it. Now, like I said, it's actually going to do that without the parentheses, but just for the sake of like being consistent and always explicitly controlling your order of operations with parentheses, you end up with clearer, more explicit code this way, even if the parentheses aren't necessary. So we'll do that as well. And then that'll have that. So one thing that could get a little weird here is, since we have two ifs like this, we change the value of val, we change val, and then the second if is going to run, but our counter didn't increment. And I guess we could get around that by just incrementing our counter in here, but instead we could just chain these two conditions together and just call this an alif and check the opposite condition. Now, as it happens, every integer is either positive or negative. Or excuse me, every integer is either even or odd. I was like, wait, positive or negative? So if it's, we can check if it's even, and if it's not even, then it's odd, so we can just say else. So if val mod 2 equals 0, then val is even, else val is odd. And then we can do this val equals val times 3 plus 1 right there. So let's try this out. Let's see if we get, okay, so we get a different error here. So if you have like multiple things that you want to return in your function, you can just return them just like that. Awesome. And it looks like we got 16.0, so I don't know if that float's going to throw things off. I am going to cast this as an int like that. Yeah, that should do, because this shouldn't cause any problems, because we're only dividing by 2 when the number is even, so it'll always be evenly divisible by 2. Perfect. Okay, so this did give me 10, 16, and 6, which is what I expected. There's still a chance that this could fail. Now let me go do a little bit of cleanup here. We did end up using data, or at least I didn't in my code. You could have written this to utilize that list like that, but I didn't in my code. So actually, here, let me just, I'll copy it to here, and I'll paste it in here. Okay, cool. Let's see if that's actually going to run. Correct. Awesome. Hopefully that was helpful. And I'm going to paste this in just as a matter of good course here, because why not? Let me know if anybody's got any follow-up questions to that. Or if you've got another question, then that's great too. I'll put a minute on the clock and just wait if anybody's got another question. All right, not seeing any other questions at the moment. Floor is still open. If you want to put one in, do feel free to do so. But since I'm not seeing anything, we can just go grab a problem off of Code Wars. And I thought I'd do kind of a harder one. Let's see here. Oops. So I thought I'd jump in and do like a 6. There's one that I wanted to just see if I can find here. Vowels back. So I've done this one before, but I thought it was interesting, and there's enough, I don't know, there's enough going on that I thought it'd be good to solve on stream here. So This is a level 6, so it's a little bit harder. If you're not familiar with Code Wars, I'll just give you a quick rundown here. So I think when you start off, you're going to see this dashboard. And what I like to do is come down to kata, click on kata, and then just select the difficulties that you want to do. So if I wanted to do 8s through 6s, just click and drag 8s through 6s like that. And then you can just find whichever ones you want. The harder problems are the lower numbers, by the way. The Q is the difficulty, Q or whatever is the difficulty of the problem. So an 8 or 7 Q problem is are pretty easy. They're meant to be like beginner level problems. And then the 1s and 2s are like very, very challenging problems. But 6s are starting to have a little bit of challenge to them. So let's just look at a 6. So I'm going to start this one out. I'm going to make a doc string. It's kind of good that we're talking about doc strings today. Or really, I'm not actually going to make a formal doc string, but just a comment somewhat like a doc string. And I'm going to steal the tests. So on the left is your problem statement, and I always like to copy that into my editor. And then on the right, you have your space to submit your code. And below that, you have some tests. I'm going to snag these really quick. This makes writing tests easy. So basically, you can see these are tests, but there's quite a lot more going on than my simple print tests. I'm actually going to turn these into those. So at the end of the day, it's still the same thing. If you look, it's just a call to the function with an input and some assertion about what that function should give me back. That's all it is. So I'm just going to look for any line that kind of has that information, and I'm going to use that. So those are the lines I'm interested in, and all this other stuff, we don't have to worry about it. And I'm just going to turn this into print, and there's your tests. So real quick here. I think maybe, yeah, let's go a little fancier with these. These are our expectations. Let's do this. We'll call this exp for expectation. And we'll call this we'll call this res for result. And this is the actual result of our function. And then these prints, I'll just separate them like this. These prints, I'm just going to say res equals exp. And this will just tell me true or false whether they're equal. If it's true, then I know my tests are passing. And if it's false, they're not passing. And I always like to actually see the result to make sure that I'm getting what I'm getting, especially if the test is failing and I don't expect it to. Well, this is going to print out the result so I can see, okay, how did it go wrong? How is it different? And then I can start deducing why that might not be the same. Okay, so I'll say def function. This is going to take, what does it call it? This is just going to take in a string. I'm going to call it text. And we want to return, I'm just going to say a result string, and we're going to start an accumulator. I'm just going to assume everything's an accumulator until proven otherwise. Okay, let's actually read the problem statement now. Notice I haven't even read the problem statement. I've just stolen the tests and stubbed out the function. So now we can start getting into what we're supposed to do. This one is kind of written badly in true Code Wars form. So you need to play around with provided strings. That line is not important, so we're just going to delete it. So we're supposed to move consonants forward 9 places through the alphabet. Okay. So if they pass z starting again at a, so we're going to wrap around. So if we move, let's say a w, w, x, y, z, we've gone past z, so we have to start back over at a, b, c, d. So w would turn into d. D, E. Oh, I went 8, not 9. So W would turn into an E. And then we're going to move vowels back 9 places through the alphabet. And if they pass A, start again at Z. And then this is something for our Polish friends. This kata does not count Y as a vowel. Okay, that's fine. So Y is not a vowel. I'll just say Y is not considered a vowel. Okay, so now we have some exceptions, and I'm going to kind of process these. So if the character is C or O, move it back 1 place. For D, move it back 3 places. For E, move it back 4. So I just kind of standardize this. So for C or O, move it back 1 place. I'm going to do 2 lines for this, because I really want each line to just tell me one thing. So for C, move it back 1 place. For O, move it back 1 place. For D, move it back 3 places. This is inconsistent. We'll just get rid of that. And for E, move it back 4. Okay. Oh, it's so inconsistent. Nice and consistent. Oh, so much better. Okay. So once we move a letter, if a moved letter becomes C, O, D, or E, revert it back to its original value. I'll just kind of treat this like a weird if. Okay. Provided string will always be lowercase, won't be empty, and have no special characters. So I'm not going to have to worry about numbers, special characters, or spaces is what I'm going to presume, and we're only going to deal with lowercase letters. Okay, so this whole thing is about moving values or moving letters around. It's kind of like a really weird and kind of bad encryption algorithm that's not really going to encrypt anything, or that's not really decryptable, since there are certain letters that will map to the same output. So it's a little weird, but I right out of the gate, I can think that I need an alphabet. So I'll say ABC equals, and we'll say A, B, C, D, C. Okay, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so there's our alphabet. I'm going to need to iterate through all the characters in text. So I'll say for C in text. C is just shorthand for me for character. For C in text. At some point, I'm going to have to add something into the result. And one thing that I note here is that we have this thing where if a moved letter becomes C, O, D, or E, then we revert it back to its original value. So I have to have a way to move C that doesn't make it so that I lose access to the original C, because it might end up as one of those. So I think I want to handle this right out of the gate, just to kind of remind myself. So if the moved letter is in CODE, then I'm going to say res plus gets C, else res plus gets moved letter. So I know this is how I'm going to alter res, and I'm not going to alter res in any other place. I'm just going to do it here. So I know everything is going to be building up to this. So this is actually going to go at the bottom of my for loop. This is something that I want you all to keep in mind. I think I see some people, and I think people sometimes, you may find that you're like uncomfortable writing code and then like writing code above that, writing code that you're not going to write something afterwards, but it's really common, at least for me, like I'll write something and then I'll write above that. You're like always working on the middle of a document or the middle of a function. So it might feel a little uncomfortable to like not write like top to bottom, but it's a good habit to try to break because you're never really able to do that. So I know that this is how I'm going to alter my res, and that alteration is going to happen after I've determined what moved letter is. So let's create a moved letter. I'm just going to create it right here and initialize it right here. And I'm initializing it right here just that way so it gets erased, the previous value of it gets erased at the beginning of every loop. And it'll get erased as an empty string. That way it kind of resets itself, just in case that becomes important later. So I've got to do this whole thing where I'm moving the letters. This is like my primary case logic. This is what I would call the primary logic. These are exceptions, and in general, we want to handle exceptions or edge cases, whatever you want to call it, exceptions and edge cases. We want to handle those first, right? So, and this actually kind of fits into that as well. That's kind of why I want to get it out of the way. So let's handle these edge cases first. So basically, I'm just going to say if C equals C, then I'm going to say moved letter equals C minus what? 1? That's going to be, we're going to move it back 1. So C is going to become B. Okay. Alif C equals O. We're also going to move it back 1. So 1 before O is N. And then D is going to become C. Oops, nope. Move back 3. Sorry. 1, 2, 3. So D is going to become A. And where's the next one? E is also going to become A, I think. Yeah, 1, 2, 3, 4. Yep. So actually, in this case, I'll just do it if C in D or E. So if it's either D or E, we're going to move it to A. Okay, cool. So that should handle my edge cases. So false. Currently, we're getting falses, but I just wanted to run it at this case. So you can see I expect this. I have this input, which is test case, and the output should be tab to and I'm getting task basa. Okay, so I've definitely done something to it. I've handled the edge cases. I just wanted to make sure that like something is happening in my output. So we're good to go. So now let's handle the primary case. The primary case will chain off of the edge cases. So we'll say alif, and it's just vowels and consonants. So I'm going to do vowels. So this will be vowels. C is a vowel. I'm handling two of the vowels, O and E. So from here, I can just say if LFC in A, E, I, O, U, but we don't need O and we don't need E since those are part of our edge cases. So we'll just do A, I, and U, which is kind of weird, but then I'll just do this as a placeholder for now. Is a consonant. Did I spell that right? Consonant. Up. I did not. Okay. So this will just be an else. So in this case, C is a vowel, and in this case, C is a consonant. And we're going to determine what the moved letter should be. Okay, so here's where things get kind of interesting. So this is the primary logic. It's kind of like the main case of the problem. And basically what we want to do is we want a letter from ABC. And I make that assertion based on these statements, right? So we move consonants forward 9 places through the alphabet. So when I have a consonant, I want the moved letter to be the letter that was 9 places forward to the right of that consonant. So I know that whatever that letter is, it's from ABC. Do that here too. So it's a letter from ABC. So I know I'm gonna like index into ABC. Just try to do this in one place. And I've got to move it 9 places forward. So first of all, I've got to find the index of C, so I know where to start, right? The index of C in ABC. So in order to do that, it's ABC dot index C. Why don't I kind of feel like calling this C, since we're dealing with letters, I should give this kind of a better name here. So why don't I call this CH, is it CHR? I'm just going to call it CH, okay, for character. So the index of CH in ABC is abc.index of CH. Okay, so let's look at this. We've got a T, right? So the index, so when we iterate through CH in text, the first letter in the first test is a T, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I started at 1, so that's actually index 19. So ABC sub ABC index of CH of character gives us back that character from ABC. So since index gives me back an integer, I can do math with that integer. I can add 9 to it. I can say plus 9. Good, perfect. So we have an error. Oops, that's an indentation error. Fine. I'll just do this. So if I try to Oh, wow. How did that not throw an error? Huh. I thought that would be throwing an error. That's interesting. Let me try this. 20, let's try index 30, because I know there's not an index 30. Yeah, that should have been out of range. Why is that not out of range? Why is that not out of range? Let's try that. Am I totally just wrong about this? Uh, 19, 20, 21, 22, 23, 24, 25. Yeah, so let's find out here. I'm just going to make a special test case here where I just have a nice, simple input that I understand. So T should transform to, might transform to T. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So T should transform to C, which is on the exceptions list, which means it should be code. Oh, I see why that's not causing an error, because this is the vowels case. My bad. I totally understand what I'm doing at this point. Let's just try W. I do want to write this test case actually though. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So W should turn into F. Okay. And I'm handling consonants, so I should be doing that there. Okay. Finally, so this is the error that I thought I was going to get. So the move letter is ABC sub index plus 9. So this would give me the right index, but it'll also give me a number potentially that is larger than the largest index. So what I need to do is make sure that if I get an index of 26 or more, that starting at 26, 26 should give me an index of 0. So I'll take this whole thing, take this whole part, and do mod 26, since I know there's 26 letters in the alphabet. Okay, so W turns into F. And then let's make another one. A should go back 5 places. So A is a vowel, so A, 0, 1, 2, 3, 4, 5. So A should turn into V. A should turn into V. So false, A does not turn into V, and that's because I haven't written that logic yet. So let's write that logic. So it should be the same, but instead of adding 9, I just subtract 5. So V, A turns into V, and F, or W turns into F. And let's see if that's going to make these pass. There you go. True, true, true. And let's submit this into Code Wars. And let's attempt it. Cool. So my tests passed. The attempt succeeded. Now, one thing we could do, there's a number of ways we can we can approach this. But we could refactor this. Let's see what the time is. I'm not sure I really have time to like go through refactoring this. Do I want to do that? I think, yeah, why not? Why the heck not? I think we could refactor it. We could totally refactor it. Okay. So one thing that I noticed, and I wanted to bring this problem up because you do all this work and you end up with code that really isn't that glorious, right? This is kind of like clunky, straightforward code. To be clear, like this is fine. This solves the problem. This works. And I want to kind of normalize writing code like this. It doesn't always have to be like the fanciest mega code. Definitely not your first trip through solving a problem. Writing code like this is nice because it's very sort of straightforward and step by step. You get a sense of how a problem is solved this way. But what I see a lot of people trying to do is trying to solve problems with comprehensions first. I'm not going to say that that's not possible. It's just while you're learning and while you're new in a language, and I mean myself, I just out of principle I do things this way first because it's just really easy for me. And then if I look at it and I think, can I refactor this into a comprehension? Do I want to do that? Then maybe I'll refactor it into a comprehension. So just for fun, let's refactor this into a comprehension. So I'm going to change the accumulation to be list accumulation. So we'll do dot append. And this is our modification step. So this is going to take kind of a straightforward approach. We're going to turn this into a ternary. And we don't need to actually do the append anymore. We'll just do ch or moved letter. And moved letter really is just moved letter is really just going to be these values. So we're going to do this. If CHN that else this. Okay. There's that. One thing that I notice is I'm going to have to, since this is a list, I'm going to have to join this string.join like that. And now we need to handle these edge cases. Oops, I forgot this part. If CHN here, okay. This comprehension is getting quite nasty. We've got to do CHN text at some point. And then get rid of that. And we've got to handle these up front. So let's just get rid of these colons. We're going to turn these into long, weird ternaries. Oops. Okay. So I'm going to say else if, And these alifs are going to just change to if. Okay. Okay, so if ch equals c, so this is going to be b. B if ch equals c, else o, else n if ch equals o, else a if ch n de. Okay. So that's going to go, right. And I just realized that can't be happening. I think that's going to go right up front. Like that. Okay, so there's my edge cases. And I've got to do a little recollecting here. Let me just pop this up here for reference. Okay. Got to handle those, comment those out. Okay. So B if ch equals c, else n if ch equals o, else a if ch n d or e. So for this whole thing, it's going to be ch if this whole thing, whatever that resolves to, oops, this is going to be part of that as well. So that's the moved portion. So if this moved portion is in, so if the moved portion in CODE, then we do CH. We'll do it the other way. This, if not in, if this not in code. Okay, that's what, dang, I literally have to do that. Else ch for CHN text. Whew. That is a beast of a comprehension. And of course, let's just join. And we'll return it. Okay. I'm not entirely faithful. Oh, I've got invalid syntax, you don't say. For ch in text. Oh my gosh. Okay. So this comprehension is totally out of control. Yeah. All right. I have to go completely start over with this one because that just got totally weird. All right. So anyways, sometimes that happens. We're about at time though. I think I'm just gonna throw in the comprehension for this after the fact and wrap up here. But yeah. Cool. Sorry about that. And hopefully everybody's doing good. Let's see. We did have another question here. Yeah, sorry to leave you hanging. I will take this last question because I don't want to just leave you hanging. Okay. I'll give that one. Come back and do that one later. So this one, which question is this? Import math, factorial, Cartesian product of factorial for Q1. So this is for question 1. Okay. Yeah, this is actually a long, I've taken this question on stream before, and it's actually kind of a long answer. I'll sync up with you about this after stream so we can go over it because I don't want stream to go on too long. But yeah, I'll wrap up here. To the person who asked this, expect a DM from me, and we'll just chat about this in a few minutes. So, all right, I'll see you all later. Cool. Bye bye.